Question 8 in 2020. A company has designed an aptitude test for people applying for jobs. The aptitude test is scored out of 500 and the results are normally distributed with a mean of 280, standard deviation 90. If I do a sketch of a normal distribution, what's happening here? Here's my mean of 280 and I have a standard deviation of 90. Top 25% of people are invited back. Find a minimum mark required. So look, we've 25% in here. That's 25%. We're going to invite them back. So what do they have to score? So this would leave 75% to the left of it. So we're looking to find 0.75 in the Z-score table. And if we go to the Z-score table, it's between two numbers. 0.6 on the left is going to give the 7 and the 8 0.07, and 0.08 are going to give me the midway point 7486 and 7517. So if we take the midpoint of these two, our Z-score is 0.675. It does make a difference in this question if you don't go to the midpoint. You get 1 mark off, but it doesn't tell us to round, so it's probably acceptable in the leaving cert to take 0.67, but for more accuracy 0.675. So we're testing X, our test statistic. We don't know what it is. We're testing it against the average over standard deviation. This is my Z-score. So if I fill that information in, X minus mu, which is 280, divided by 90 is equal to 0.675. So X is equal to 0.675 by 90 plus 280. That's going to give me 340.75. So we'll say X is equal to 341. It doesn't ask us to round, but maybe write both if they don't ask you. Either one of these two numbers. Anyone who scores above the 40th percentile can resit the test. So if we do a sketch again, this is 50% over here. So we're looking for a mark down here. So someone has to be in here. They would have to be, what would have to be, there would have to be less than 40% in here for them not to be able to resit the test. So we have to see this. This has to be greater than 40% in here for this to be in the top 60. So let's have a look at testing 260. 260 minus 280 over 90 is going to give me minus 20 over 90 minus 2 over 9, which is 0.2. 11 is 2, 2, 2, 2 repeating. Minus, and if I go to 0.2 and take my 0.2, it's going to be close to 60%, 5871.5871. We could go a little bit higher because it's 0.22, but we don't need to leave insert. So we're saying that this score here, over here, means that we have a normal distribution table where my score here of 260 means that there is, in this sector, 1 minus 0.5871, which is equal to 0.4129, 4129. So there's 41.29% of people in this sector. So we could say Eileen scored better, or scored in top 58.71%, therefore eligible to resit. And that's all that's needed here. Explain the relevance of the Z-scores in the standard normal distribution. Well, this is plus or minus 2 standard deviations. So we say, well, here's my mean, here's my minus 2, and here's my plus 2. But these are more accurate than empirical rule. Which is 68, 95, 99.7. So when we get 1.96, a Z-score of 1.96, it's going to give me 0.975, which leaves, if you imagine, 2.5% in there. and 2.5% in there, which is your 95%. This empirical rule of 95%, which is 2 standard deviations, but 1.96 is more accurate than the empirical rule for 2 standard deviations. I'll just do this away from the mean. Part 2, Transky Airways surveyed 2,500, we have an N here, 2,500, about a new service. The variable P hat, I'll just call it P in this question, I'll change to P hat at the end, is the proportion of respondents who said they would use the new service, and the radius of the 95% confidence interval of the survey was this. So this brings in standard error. Standard error, find the value of P, and it's between 0.5 and 1. So standard error, these things in stats you need to know. 1.96 when we're dealing with P, by the square root of P times 1 minus P over N is going to be equal to the radius of my 95% confidence interval, or my standard error here, 0.01568. So if I fill my values in, 1.96, I've only one unknown here, P hat or P. 1.96 by the square root of P times 1 minus P over 2500 is equal to 0.1568. So if I divide by 1.96 rather than squaring, I can get the square root of P times 1 minus P over 2500 is equal to, that's going to give me 0.000, just 2 zeros, 008. So if I square across, if I square both sides, P times 1 minus P over 2500 is going to be equal to 0.008 squared. So I'm actually going to bring the 2500 over to it, and then I can multiply it out. P minus P squared is equal to this guy here, all multiplied out, 0.16. So if I bring P squared minus P to the right plus 0.16, and if I multiply by 100, it should factorize. These should factorize in these questions, so I'd always check the factorization first. Plus 16, 100p squared looks like 10p times 10p. If it's not, we could try 20 times 5. 16 is 8 by 2, and you can see 80 and 20 will give 100, so yeah, it does factorize easy enough. So p is equal to 2 over 10 or 8 over 10. I think we said it had to be between half and 1, didn't it? Yeah. So p hat in this case is equal to 0.8. So I'll do the second half of this video this question in the next video.